sometimes you'll run into a question that has a shortcut. 2a has a shortcut. I'm going to show it to you, and then I'm going to do it as if you didn't notice a shortcut. Because shortcuts are nice if you notice them, but sometimes you do a question and you're like, I don't remember how to do a shortcut and I missed it. What would that look like if I just did it regular? So I'll show you the shortcut first. In A, you're like, oh, it's a log equation. I need to combine as a single logarithm. And you notice that you're adding with the same base. Adding with the same base means that you can multiply inside the logarithm. And the shortcut happens in this situation where you have log on one side and log on the other side with the same base. It's very similar to a shortcut that we used when we solved exponential equations with the same base. We did this, so 6x would have to equal x plus 6 times x minus 1. Do you see the shortcut? If log of 6x is equal to log of x plus 6x minus 1, does it make sense that the green boxes would have to be the same? It's the same thing as when we did 5 to the x plus 3 equals 5 to the 7. You would say, oh, so x plus 3 equals 7. And you wouldn't, you know how yesterday we solved those equations by taking the log of both sides? You could still do that, and that's the proper technique, but that's a lot shorter, right? It's a shortcut for you. So in this one, if you use the shortcut, you would get 6x equals x plus 6, x minus 1. Have you solved equations like this before? Yes, it's going to be an x squared equation. How do you solve an x squared equation? Well, you can factor, but only if the one side's equal to 0. Right now, it's not equal to 0. So we're going to have to expand this side. Subtract 6x on both sides and combine your like terms. Make it equal to 0. And now you can check, can we factor this? Yes. X minus 3, x plus 2. So x is equal to 3 and x is equal to minus 2. And the last thing that we need to do is we always need to check our answers to see if in your original question, so I'll scroll up just a bit so we can see the original question, do I ever take the log of a negative? So I tried 3 first. If I plug in 3 here, I get 18. Perfectly fine. 3 plus 6, 9. Positive number. Perfectly fine. 3 minus 1, 2. Positive number. Perfectly fine. So I know that x equals 3 works. But if I plug in negative 2, 6 times negative 2 is negative 12. I don't even have to check the rest. Once you get a negative once inside of a logarithm, that answer gets canceled out right away. Now, if you did not, I'm going to draw a line here, and say you missed the shortcut, what would this look like if you followed the rules normally of solving a logarithm? The normal solving a log equation is that you first have to get a single logarithm, so you can do the weird step of using the definition. From here, we don't have a single logarithm. We have a log on one side, a log on the other. If I want to get a single logarithm, I'm going to need to combine them. That means I need to have them on the same side. So I'm going to subtract the log 6x on both sides, move them to the same side, and then say I have a log law that says if I'm subtracting, that's the same as dividing inside the logarithm. And now I have a single logarithm. Once you have a single logarithm, that's where we use the weird step and say, okay, I can change this to exponential form. My base is 10. My exponent is 0 equals x plus 6, x plus 1 over 6x. 10 to the 0, of course, is equal to 1. And we're left with a rational equation, which you solved in grade 11. X minus 1, thank you. Change that to minus and minus. How do you solve rational equations? You get rid of the fraction. I can get rid of the fraction by multiplying both sides by 6x. That would give me 6x equals x plus 6x minus 1. And all of that extra work just to get to where we got with the shortcut quickly. You see that now we're back to where the shortcut got us in one step? Probably why it's called a shortcut, because it's shorter. Should they call the other method in this case the long cut? Would that be like a proper English thing to do? Give a shortcut, long cut. Okay. So after this, you would solve it. It would be exactly the same. Let's go to part B. Part B, we start off with 3 equals log base 2 of x plus 2 plus log base 2 of x. Again, you're solving for a log equation. You want to get single logarithm. We can do that because we notice that we're adding. Adding is the same as multiplying. Can't use the shortcut here because it's not log equals log. But what we can do is use the step that is weird. Once you have a single logarithm, you can change it to exponential form. The base is 2, the exponent is 3, and if I distribute this, I will get x squared plus 2x. Quadratic equation, how do you solve quadratic equations? You make one side equal to 0. So I'll subtract the 8 on both sides. It factors nicely. And you get x equals minus 4 and x equals 2. Once again, you need to check your original equation. Minus 4 does not work. Plus 2 would give you 4 in this one, 2 in this one. They're both positive. That's fine. That answer works. Now, at this moment, we have now solved 4 different logarithmic equations. And I'm a little bit frustrated with the textbook because they're leading you down a dangerous path. Every single time we got a negative answer, we put an X through it. And every single time we got a positive answer, we put a check mark. And what that leads students to sometimes do is go, oh, maybe there's a shortcut. Maybe every time it's negative, I should just put an X through it. And every time it's positive, I should check it off. The answer to that is no. You always, 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 in order to find out these work or not, you have to plug them back into the original equation and check. I can make a question where I give you 2 answers that are both positive and both of them don't work. I can make an example where I give you a positive answer and a negative one, and the negative one works and the positive one doesn't. I can give you a question that has both answers work or both answers not work. There's lots of different options. It is just maybe bad planning on the textbook to give you 4 examples in a row where the positive one works and the negative one doesn't. So a little bit later, not today, but a little bit later, I will give you some practice examples where you have to check, because the negative ones work and the positive ones don't, and vice versa. Right? But we are programmed that way to look for patterns. And once you notice something like, ooh, the negative ones always don't work, then you start to do it in a shortcut way, which could cause you mistakes later on. So you always have to check the original equations. Okay, practice questions for this one are 11 and 13.